Hello Algebra 1, today we are reviewing for your quiz 3 of Unit 10, which is our last big unit of the year. So first we're going to start off by just factoring completely. So again, there are no equal signs, so we're not going to be solving. So once we factor and get our problem into the parentheses, we are done. So you're going to notice this first problem is not set up like our box problem, x squared x and a number. So this means we're looking for the biggest number that comes out of all three of these, which is just going to be a 3. And then we're going to check each variable, and in order to be a part of our GCF, every term has to have our variable. So I'm going to check my x's. Does everybody have one? Yes. So I go with the smallest, x cubed. And then I check my y's. Does everybody have a y? No, they do not. So that means y is not a part of my GCF, and I can open up my parentheses and keep going. Now I treat this like distributive property. 3 times something is 27. That's 9. I'm starting with an x cubed, and that's what I need to have, so I'm all set there, but I do need my y to the 7th. All right, now I go on to my next term. 3 times something is 9. Well, that's a 3. Bring down your minus. I only have 3 x's. I need to get up to x to the 4th, so I need one more x. And now I'm ready for my last term. Bring down your plus sign. 3 times something is 3. Well, that's just a 1. I have 3 x's. I need to get all the way up to 5. That means I need 2 more x's. And I need that y to the 3rd. And there you go. All right, now our next problem, this is set up like a box problem. It has x squared, x, and a number. You have a 1 in front, so we can go straight to our add and multiply. I'm multiplying to negative 36, and I'm adding to 5. And those numbers are a 9 and a minus 4. So I just have x plus 9, x minus 4. Now, number 3 is also a box problem, but it has a 2 in front. So this is actually what we call Gcf Box. We are going to have to divide that 2 out first, okay? So 2 has to come out of every term. 2x squared divided by 2, x squared. 26x divided by 2, 13x. 44 divided by 2, 22. Now I'm ready to do the box problem part of this. Okay, so add, multiply. I am multiplying to 22, and I'm adding to 13. Think about those numbers for a minute. They are 11 and 2. All right, so bring down your 2. Whoops. Try that again. Bring down your 2, and then we have x plus 11, x plus 2. All right, and there you go. That's just your answer. All right, now number 4 isn't quite in our form that we want it to be in. We want x squared, x, and a number. Here, everybody has one more x than they're supposed to. So that means that x is our GCF. And when we divide out our x, we're just taking away one x from each of our terms. Okay, that x just gets divided off. And now what's left over inside our parentheses, this is what we're going to do our box problem with. All right, so multiplies to negative 15, adds to negative 2. Go ahead, think of those numbers. We're going to use a 5 and a 3. Which one would be negative though? It's going to be that 5. So make sure your x stays out front. That's your GCF. And then we have x minus 5, x plus 3. And here's your factored form. Now, number 5 has 2 issues. It still has, everybody has an extra x, just like in number 4. But you also have this 3 out front. So we're going to have to divide that 3 out as well. A 3 and the extra x. Okay, so we're dividing our terms by 3, and we're taking away that extra x. So this will just become a 1, x squared. 9 divided by 3 is 3. Take away an x. 54 divided by 3 is an 18. Take away that x. So now that x is gone. And again, what's left over in your parentheses is what we're going to do the box problem with. All right, multiplies to negative 18, adds to negative 3. All right, so take a minute. It should be a 6 and a 3, but the 6 should be the negative 1. So bring down your 3x, and we'll have x minus 6, x plus 3. All right, last one of these, number 6. This looks like a box problem, kind of. You're missing your number, but I would not recommend you treat it like a box problem. Instead, I would recommend you treat it like the first problem, okay, just a GCF problem. You can take the 5 out of both 5 and 10, and they both have an x. The smallest one is just x. And then think of it just like distributive property. 5x times something is 5x squared. Well, that's just 1 and an extra x. And 5 times something is 10. That's 2. We don't need that extra x because we already have it. And that's it. If you treat it like a box problem, you'll have to divide out the 5 and then do the box problem, so it will take longer. All right, so before we start solving, let's make sure you understand how many solutions you should have. So in order to figure out how many solutions you're going to have, you should look at your degree. For example, this problem has an x squared, so we should expect to see 2 solutions. This next one has an x cubed, so we should expect to have 3 solutions. And finally, an x squared again, so we should expect to have 2 solutions. Now, sometimes there are special cases, but for the most part, this follows true. Now we're going to practice solving. This is where we're going to use zero product property. We're going to factor first and then set everything equal to 0. So to start off, this one is already in factored form. So I'm just going to go ahead and set each part equal to 0. So that part's done. 2x plus 1, I'm going to set that equal to 0. And x minus 4, I'm going to set that equal to 0. Okay, and now I'll go ahead and subtract my 1 over. And divide by 2. And here's my next solution. X equals negative 1/2. And then the final one, I'll just add my 4 over. And x equals 4. Okay, so that one again was already factored for us, so we just had to find the solutions. Okay. Next, this one we're going to have to factor, but first we've got to get that equals 0. So to get my equals 0, I will add my 19x over. And since it's my x term, it should go in the middle. That's going to be my add number. There we go. I'm going to check. I do just have a 1 in front of the x squared, so this is ready to do my box problem. I am multiplying to 18 and adding to 19, and that's just going to be 18 and 1. Equals 0. And now, because there's an equal sign, I need to solve. X plus 18 equals 0. X plus 1 equals 0. Subtract. And subtract. All right. Next, number 9. Again, we have to have an equals 0. So we need to start by adding over that 42. This time, though, the 42 is just a number, so it's just going to go at the end. I do have x squared x and a number, but this time I have a number in front of x squared. So before I do my box problem, I do have to divide everything by 3. Okay, so 3 times something is 27x, that's 9x. 3 times something is 42, that's 14. Don't lose that equals 0. All right, so that's really important. You do have to divide out that 3 before you do your box problem. So now the box problem is taking place with these numbers, not the ones above it. All right, so I'm multiplying to 14, and I'm adding to 9, and those numbers are 7 and 2. Don't lose your 3. Okay, so this is our factored form. Don't lose your equals 0. And now remember, when we solve, 3 can't be equal to 0, so I can just ignore that. But both of these guys have x's, so I do need to set both parts equal to 0. All right, and then I'll just go ahead and subtract. So negative 7 and negative 2. Also remember what we talked about above. Your degree here is a 2, so you should expect to have 2 solutions. All right, number 10, we do have an equal 0, which is great, but everybody has an extra x, which is not so great. We should have x squared x in a number, and instead we have x cubed, x squared, and x. So everybody has an extra x. We're going to have to take care of that. We also have a number in front, so we're going to have to take care of that as well. So we are going to take out both a 2 from everybody, and we also have to get rid of an x. Okay, so we're dividing by 2, and we're taking an x away. That leaves us with an x squared plus 20 divided by 2 is 10. Take an x away. 48 divided by 2 is 24. Take the x away. All right, so everybody should now have the right exponent. X squared x and then our number. Okay. All right, so now we are ready to do our box problem with this. We are multiplying to 24 and we are adding to 10. And those numbers are a positive 6, so x plus 6, and a positive 4, x plus 4, equals 0. Now remember, this had a cube, so we should expect to have 3 different solutions, and we will, because we have 3 different places where there are x's. Go ahead, set each part equal to 0. And now we'll go ahead and solve. Divide by 2, divide by 2. Subtract 6, subtract 6. And subtract 4, subtract 4. So 3 different solutions, 0, negative 6, and negative 4. All right, the last 2 we're going to do are 11 and 12. We are skipping 13. Number 11, again, you don't have an equal 0. So we will start by subtracting that 15x over. And ordinarily that 15x would go in the middle, but if you notice here, everybody has an extra x. We have x cubed, and we have x squared, so this 15x actually needs to go at the end. Now there aren't any numbers in front of our x cubed, but like we said, everything does have an extra x, so we are going to have to divide that extra x out, and we just take an x away from each one. Okay, so your numbers are staying the same, it's just when we divide out that x, each of them drops by 1. And now we are ready to go ahead and do our box problem here. Okay, so we're going to multiply to negative 15, and we're going to add to 2. And again, this will be a 5 times 3, but we want the 2 to be positive, so it'll be 5 minus 3. And now we solve. Set x equal to 0. This one's done. Set x plus 5 equal to 0. And subtract 5 over, so negative 5. And x minus 3 equals 0. Add the 3. X equals 3. All right, and last one for today, number 12. So we do have a GCF of 3 here, so we're going to divide that 3 out. And once you get this, you may notice that this is a difference of squares problem. This is the type of problem where we know we are multiplying to negative 9, but we are adding to 0. And those numbers would be a 3 and a negative 3. So I still have that GCF of 3 out front, and then I have an x plus 3, x minus 3 equals 0. I don't need to set this 3 equal to 0 because it can't be equal to 0. Instead, I just set everything with an x equal to 0. And minus 3, first solution, at least for me, is x equals negative 3. Add 3, and my other solution is x equals positive 3. All right, and there is your factoring review for quiz 3. I hope you have a great day. Bye.